Alright, so for number 10, remember you were supposed to find the factors of the top over the factors of the bottom. So you took the factors of 32 with plus or minuses over the factors of 1. Okay, and then 12 and 14. Just going down to start. Okay, and then 16 got a little messy. Okay, and then 17's in green. Okay, and then for something like number 18, what you had to do was take into account that it was a square base. So what that meant is that the corners of the base were being cut off and they were x's. So you had to cut off the edging, which was x. So you cut out your corners, and that gave you that this length here was 28 minus 2x, which meant that that was this length here. So your height, length, and width were represented by 28 minus 2x, 28 minus 2x, and then a height of x. Yes?
Can I fill up my water bottle with you?
Yes. Okay, we'll go over the rest of that in a second here. 11 and 13. Okay, and then 15. So remember, all of the potential answers are the top number divided by the bottom number. So like 1, 1/2, 1/4, 1/8, 2, 1 again, 1/2 again, and 1/4 again. 3, 3/2, 3/4, 3/8, 6, 3 again, 3/2 again, 3/4 again. So a lot of them end up repeating. 7, 7/2, 7/4, 7/8, 14, 7, 7/2, and then 14/8. and so on and so forth. And then to finish out 18, okay? And then I actually ended up, even though you did not need to do it, I did an example like 19, just so you could kind of see, and we're going to do another example similar to 19 today. So in 19, you have x cubed plus 10x squared plus 31x plus 30. So what I did was find all of the p divides q. And then I used the rational root theorem, and I said, okay, this is positive, positive, positive. That means there are no positive zeros, which meant that none of these p divides q could end up being positive. So I started by plugging in positive 1 and was like, wait, that doesn't work. So then I plugged in negative 1. It didn't work. Plugged in my next value, which was negative 2, and got 0. So that told me to use synthetic, which got me my quadratic, which allowed me to factor. And that made me recognize that I had 3 real zeros at negative 2, negative 3, and negative 5. And what you should notice is all of those are up here in my rational root theorem. So we could look at another example. I really like, for example, number 26. To me, this is a quartic that becomes kind of like a quadratic. So you have 256, which is a perfect square. You have 81, which is a perfect square. We know that we have a sign change from here to there. So that tells me I have at least one positive real. If I plug in a negative x, I end up with the same answer. So that tells me I have one negative real, which tells me that I have 2 imaginary, to give me my grand total of 4. It's going to factor like a difference of squares. And then we can set each one equal to 0 and find our roots. And again, if we'd have done p divides q, you'd have had all the factors of this over all the factors of that. Let's do number 25 as a p divides q. Okay? So you have plus or minus 1, plus or minus 2, plus or minus 4, over 1, 2, and 4. And again, if you take into account no sign changes, so that's no positive reals, you plug in negative x, you get negative 4x cubed, positive x squared, negative 16, positive 4. So that's 1, 2, 3 sign changes. So you have 3 or 1 negative and 0 or 2 imaginary. So when I look at my p divides q, they can now only be negatives. So that's negative 1, negative 2, negative 4, negative a half, because 1 over 2, negative a fourth, and that's your choices. So then to figure out which one it was, so now you only have 5 choices. You could do a quick plugging in. So you could find f of negative 1, either using substitution or synthetic. So if I quickly plug in using substitution, I get negative 4, positive 4, they cancel. But that gives me a 1 in 16, so I know negative 1 doesn't work. So 4 times negative 8 is negative 32. 16 times negative 2 is negative 32. So again, if I plug in negative 2, it's also not going to work. So I can eliminate negative 2. And then now, if we plug in negative 4 cubes getting bigger. This is where you might want to actually apply synthetic or potentially look at synthetic for a fraction. So whenever the numbers become more complicated, that's when you want to apply synthetic. Again, this is a trial and error if you don't have a graphing calculator, which on your chapter test, I don't think you're going to get one because the whole idea is to make sure you can do these by hand. So maybe we try negative 1/2. So again, the minute I see a fraction within that problem, I'm thinking, okay, it's not going to give me that 0. And you can almost stop. Like, you don't have to continue if you know it's not going to work. again, the idea would be, that as you continue to plug these in, what happens if you get a problem in which none of your factors or roots are working? What that means then is I'm looking at this case here where I have 3 or 1. It's obviously not going to be 3. So I'm down to my last rational 0. So let's try negative 1/4. And we notice that the last one does in fact work, which tells me that I have this case right here of 1 negative and 2 imaginary. These now represent the coefficients of my quadratic. And so what I can do is then solve. So I get my 2 imaginary and 1 real. So I have a kind of review to go through with you today and tomorrow. Here. All right, so let's start with the process. So if you get a polynomial function, then the steps are pretty simple. Each time you get that function, you're going to start with the rational zero theorem, which says that you want to find all of the possible rational zeros. So we're going to look at this, and we're going to determine, okay, how many positive and negative can it have? And then use that to determine my possible rationals. So I have a sign change, and I have a second sign change. So that tells me that this has 2 or 0 positive real roots. If I look at negative f of x, this stays x to the 4th. That stays negative x squared. The 8x is going to become positive, and then the 24 stays positive. So I have 1 sign change, 2 sign changes, so it means I can have 2 or 0 negative real roots. And again, if I can have none, then that means I can have 4 2, or 0 imaginary. So this is what we call Descartes' rule. The possible rational zeros can now be all plus or minuses. So the factors of 24 over the factors of 1, which are simply 1. So the factors of 24 over the factors of 1, which are 1. Which is nice because it means there's no fractions or ideas like that that we have to work with when we work out this problem. Okay, and then the idea would be that you're going to either examine the graph or use a given root. So if we were to examine this graph, on our graphing calculators, you would type in x to the 4th minus 6x squared. And for tomorrow, for Thursday, since there'll be no calculator, I would give you the graph or give you the root. So I might give you this screenshot here. So I would show you that we're in quadrant 1 and that there is in fact an x-intercept, meaning that the graph does in fact cross that x-axis. But what I would hope for you to notice is the graph touches but doesn't cross. If a graph touches but doesn't cross, that tells me that it's what we call a repeated root. It's called a repeated root. And hopefully what you notice is that that is at positive 2. So what we're going to do is say, okay, now according to my graph, I have a positive root at 2. It is what we call a repeated root. And then we can use synthetic division to get this down a factor. We have to put in a placeholder of 0 because there's no cube term. I know that 2 is a 0, so I know I'm going to get 0. And then the reason I kept specifying that 2 is a repeated root is because we can actually use 2 to divide this twice. So since 2 is what we call a repeated root, then that tells me up here my 2 positive real zeros are going to occur, and then 2 of them are at 2. So I'm actually going to use synthetic division with 2 again. Now, using those same new numbers. So we're going to go 2, 1, 2, negative 2, negative 12. So that gives me my two positive reals. So it's now down to whether these are two negatives, which we know they can't be because the middle term is positive. So once I get to this point, I'm going to use quadratic formula. So 4 times 6 is 24. 16 minus 24 gives me negative 8. So again, that shows me my imaginary solution. So negative 4 divided by 2 is negative 2. The square root of 8 is kind of like the square root of 4 and the square root of 2. So that brings out a 2, and 2 over 2 is 1. So I get negative 2 plus or minus I square roots of 2. Only because I simplified all of the 2's. So when you would write out your solution set, it would be these negative 2 plus or minus I square roots of 2, and then x equals 2. And you have to know or take into account that this has a multiplicity of 2, or is what we call a repeated root. So it's kind of like a quadratic whose vertex is on the x-intercept. You only see one real 0, but we know in factored form, it's like that number doubled for that perfect square trinomial idea. Questions, comments, concerns? Does that help? This is kind of like the big idea of chapter 6. This is sort of the all-inclusive, put everything together. Can you synthetically divide? Can you factor? Can you use quadratic? Can you find the roots? Can you describe the potential roots? Okay? Go ahead and flip that handout over. The only other part really to chapter 6 is long division, and I feel like it's been a while since we long divided. Okay, so we have something like this where it might tell you to simplify. So the divisor goes on the outside. The numerator goes on the inside. It's our dividend. So then this one's a little tricky, right? Because you have to say, okay, what do you multiply 3x by to get x squared? And you would need to multiply by 1/3. So 1/3 x times 3x would give you x squared. 1/3 x times negative 8 gives you negative 8/3 x. You change your signs. Your first terms, yeah. No, it should be an 8, sorry. Up here should just be an 8. I just made it up. We don't want 28 on top and bottom. It'll get gruesome. Okay, so then you would add your 3 and 8/3 together Adding 3 to 8/3 is kind of like adding 9 and 8. Because 9/3 is the same as 3/3. And so again, you say, okay, what do I have to multiply 3x by to get me 17/3? So it's really kind of like the opposite. It's like taking 17/3 and dividing it by 3. So in this case, that would kind of be like multiplying by 17/9. So you can get your 3 out of the bottom. So if you took 17/9 and you multiplied that by 3, you'd get 17/3. And I knew how much we ate fractions, which is kind of why I made this one have fractions. And then here you just have to take 17 times 8 and divide that answer by 9. And 17 times 8, if you think about it, it's kind of like 10 times 8 and 7 times 8. We're just going to add them together. So that's 80 and 56, which is 136. So if I don't have a calculator, I'm doing math mentally. I'm taking 17 and breaking it down into 10 and 7, multiplying both by 8 and adding them. So you get negative 136 over 9. We have to change our sign, so it's minus positive. So those two terms cancel. And your remainder is that negative 38, or negative 28 plus 136/9 all over 3x minus 8. So again, this right here becomes my remainder. And just for the sake of time, that gives you negative 116 over 9 over your divisor. Okay, if I said find P of 2, given P of x equals x to the 4th plus 3x cubed plus 2x squared, or let's do minus 2x squared, I'll keep the numbers better. So if you want to find this using synthetic, it means you put your 2 in the box, coefficients across, so you bring down the first, multiply, add, multiply, add, multiply, add, multiply, add. That final box number represents the value of that function. So P of 2 is 25. If you had to state the number of zeros, no sign change, no positive, plug in your negative x, Now you have 1, 2, 3 sign changes. So that tells you that you have 3 or 1. Negative. That tells me that I have at least one real 0. So I can have 0 or 2 imaginary. My possible rationals are those p divides q. There are no positives, so it's -1 and -5 as my potential negative real rational zeros. And I could test each using synthetic. And figure out what they were. So for today, you're doing that Chapter 6 review in the packet of notes that I already gave you. Tomorrow, there will be a released video going through them with a PowerPoint and an understanding. I'll be on Zoom during class time. If you have questions for me after class time, I will not answer questions pertaining to the test. Again, if you have questions, comments, concerns about anything relating to that quiz, you would want to get on Zoom during class time.